Right now, an uninvited guest, glowing an impossible emerald green, is hurtling through our solar system, defying every rule of celestial chemistry. This isn't just a rock, it's a silent messenger, a cosmic intruder carrying secrets from a distant, alien star. And what it just did has the entire astronomy community scrambling for answers. 3I/Atlas, our third confirmed visitor from interstellar space, has suddenly burst into a brilliant emerald glow as it closes in on Mars. This isn't simply another comet turning green. The bizarre chemistry behind this glow is shattering every rule we thought we knew about comets. And what NASA's most advanced telescopes are uncovering might just fundamentally alter our understanding of alien worlds forever. Images from observatories across the globe reveal 3I/Atlas tearing through our solar system like nothing we've ever witnessed. It's no longer some distant speck of light. Professional and amateur astronomers alike are broadcasting live feeds, giving millions a real-time look at what scientists are now calling a building block of an alien planet, a fragment that somehow escaped its home system and found its way to us. The initial discovery came from Hawaii's Asteroid Terrestrial Impact Last Alert System, or ATLAS, which lends the object its name. But as more observatories locked onto this mysterious object, it became startlingly clear that its trajectory and behavior were fundamentally different. As ATLAS plunges deeper toward our sun, the solar glare is making visibility increasingly difficult, turning observations into a race against time. But the glow was just the beginning. Its true nature began to unravel as it approached a cosmic rendezvous. In a cosmic stroke of luck, Mars sits directly in Atlas's path, about to get a front row seat to the most incredible encounter of the decade. Mark your calendars for October 3rd, 2025. That's when Atlas will make its closest approach to Mars, screaming past at just 18 million miles away. NASA's Mars Reconnaissance Orbiter is already being repositioned to capture the highest resolution images ever taken of an interstellar visitor. But it's not working alone. MAVEN, NASA's atmospheric scout, and China's Tianwen-1 are preparing to scan Atlas's glowing coma with every instrument at their disposal. The European Space Agency's Mars Express and India's Mars Orbiter mission are coordinating their schedules to ensure continuous coverage. Scientists are particularly excited to observe Mars at dawn during the flyby, anticipating a pink shimmer from Atlas's tail, painted dramatically against the Martian horizon. This makes Mars humanity's ultimate test bench for studying alien chemistry up close. We're deploying an entire planet's worth of scientific equipment to analyze something carrying chemical signatures from a completely different star system. This unprecedented surveillance, however, revealed something truly mind-bending about Atlas's form and behavior. Everything changed when the Gemini South Telescope captured Atlas across multiple wavelengths simultaneously. Ultraviolet, blue, red, and infrared images revealed something spectacular. A massive anti-solar tail stretching over 50,000 kilometers into space, a length greater than Neptune's diameter. The coma itself has expanded to an incredible 19,000 kilometers across. We're watching this object transform from a tiny speck into a full-fledged, active comet in real time. Dust and ice are scattering sunlight in ways that confirm genuine cometary activity, completely demolishing early theories that Atlas might be some kind of artificial probe. Time-lapse animations show the coma growing and pulsing as different regions of the nucleus heat up and begin outgassing. Solar radiation pressure is pushing particles away, creating the classic curved dust tail we associate with comets. Yet, while Atlas behaves like a comet, it's exhibiting this behavior with materials and chemistry that don't match anything we've ever seen before in our own solar system. The physics playing out before our eyes is absolutely stunning. Sublimating ices are dragging dust particles into an ever-widening coma, while the growing tail brightness shows solar radiation pressure intensifying as Atlas approaches the sun. Distinct hotspots flare up as they rotate into sunlight, indicating different regions of the nucleus activate at different times. Perihelion is scheduled for October 29th, 2025, when Atlas will be traveling at its maximum speed of 152,000 miles per hour. Surface temperatures will reach several hundred degrees Celsius, hot enough to vaporize not just water ice, but carbon dioxide, carbon monoxide, and other frozen gases locked in the nucleus since its formation billions of years ago. Unfortunately, Earth won't see peak brightness due to solar glare, a frustrating cosmic coincidence. Still, its visible tail has definitively confirmed Atlas's natural, icy origin, opening an unprecedented opportunity to study alien chemistry in extraordinary detail. Post-perihelion observations will improve dramatically by December, when Atlas moves away from the sun's glare while remaining active enough to provide rich spectroscopic data. Astronomers worldwide are coordinating the largest international observation campaign in comet research history. Every major telescope, from the Atacama Large Millimeter Array to the Very Large Telescope, is reserving observation time. Space-based observatories, including Hubble, James Webb, and others, are all contributing to this unprecedented effort. The data we collect will help us understand not just Atlas itself, but the stellar nursery where it was born, the processes that ejected it into interstellar space, and the billion-year journey it took to reach us. We're essentially conducting archaeology on a visitor from another star. Yet, the real bombshell came when scientists looked closer at the very atoms making up this cosmic ghost. Then came the night that changed everything. During a lunar eclipse in late September 2025, when Earth's shadow provided unusually dark skies, astrophotographers worldwide captured something nobody had predicted. Atlas was glowing a vivid, unmistakable emerald green. This wasn't the subtle green tint sometimes seen in ordinary comets. This was an intense, almost electric emerald halo surrounding the nucleus, visible even in moderately light-polluted areas. The timing was perfect. The lunar eclipse eliminated light pollution, while Atlas was at optimal distance and activity level to display this characteristic. Social media exploded with images from photographers across continents, all showing the same unmistakable emerald coloration. The comparison was immediately drawn to past green comets, like the Devil Comet 12P, but experienced observers noted that Atlas's green glow appeared far more intense and possessed a different quality than anything they'd ever seen. Photography data revealed the green emission was strongest in the inner coma, close to the nucleus, gradually fading toward the edges. This distribution pattern provided crucial clues about the physics behind the emission. Under normal circumstances, the explanation should be straightforward. The most common cause of green coloration in comets is dicarbon, two carbon atoms bonded together that emit green light when energized by solar ultraviolet radiation. This standard explanation has worked for decades of comet observations throughout our solar system, but Atlas shatters expectations again. Detailed spectroscopic analysis shows no clear dicarbon signature. Multiple independent observations from different observatories have confirmed this absence, ruling out measurement errors. The lack of dicarbon emission suggests exotic or completely unfamiliar chemistry. Some researchers are investigating trapped gases, only now venting into space as Atlas warms up, complex molecules frozen into the nucleus during formation, and sublimating for the first time in billions of years. Other theories focus on unknown compounds that have never been observed in solar system comets. Atlas formed in a completely different stellar environment, possibly around a star with different metallicity or radiation characteristics. The chemical processes in that alien nursery might have produced compounds that simply don't exist in objects formed around our sun. As if the green glow wasn't enough, deeper probes uncovered a chemical profile that defied our entire understanding of comets. NASA's SphereX mission has mapped something extraordinary, a massive carbon dioxide cloud stretching 350,000 kilometers around Atlas, almost the distance from Earth to the Moon. But James Webb's analysis revealed the most shocking discovery, an extreme CO2 to water ratio of 8:1. This completely inverts what we see in solar system comets, which are typically water-rich. Atlas appears to be a dry comet, dominated by carbon-bearing compounds rather than water ice. James Webb has also confirmed carbon monoxide, carbonyl sulfide, and various dust compounds, but barely any water vapor. This composition suggests Atlas formed in a stellar environment where water was scarce, but carbon compounds were abundant. The star it originally orbited might have had different metallicity, different radiation characteristics, or different processes in its protoplanetary disk. Hubble observations estimate the nucleus diameter between 0.32 and 5.6 kilometers. Despite its relatively small size, Atlas is outgassing like a comet 10 times larger, suggesting an incredibly volatile composition with a much higher proportion of easily sublimated materials than typical solar system comets. The European Southern Observatory's Very Large Telescope has detected something that shouldn't be possible: nickel emissions in Atlas's spectrum, but no iron. In normal stellar chemistry, nickel and iron always appear together, because they're forged in the same supernova processes. This unnatural chemical separation suggests Atlas formed in an environment with completely different nucleosynthetic processes than anything in our galactic neighborhood. Perhaps it originated in a region dominated by exotic stellar collisions or unusual neutron-star interactions that we have never observed directly. Even veteran comet researchers are admitting that Atlas doesn't fit any known categories. It's forcing textbooks to be rewritten and challenging our basic understanding of how comets form and evolve. Some scientists are cautiously raising possibilities of non-natural origins, though most maintain that exotic natural processes are more likely. The absence of iron also raises questions about Atlas's structural integrity, which might explain its unusually high outgassing rate and apparent fragility compared to typical solar system comets. This isn't just a comet, it's a time capsule from a universe far older and stranger than we imagined. The more astronomers study Atlas's orbital characteristics and composition, the more evidence accumulates that this object might be far older than our entire solar system. If this theory proves correct, Atlas could be a genuine relic from the Milky Way's ancient past, a fossil sample from when our galaxy looked completely different than it does today. Current models suggest Atlas might have originated in the Milky Way's thick disk, a region of older stars that formed between 8 and 13 billion years ago when our galaxy was young and chaotic. During that era, stellar formation rates were much higher, supernova explosions were more frequent, and the chemical composition of interstellar space was dramatically different from today's environment. This ancient origin theory helps explain Atlas's unusual chemical signature, including the nickel without iron anomaly and the carbon-dominated composition. The stellar nurseries of the thick disk operated under different conditions than modern star-forming regions, potentially producing planetesimals with exotic compositions that no longer form in today's galaxy. Atlas's retrograde orbit provides additional evidence for this ancient origin. Most objects in our solar system orbit in the same direction because they formed from the same rotating disk of material around the young sun. Atlas is moving backward relative to this motion, suggesting it approached from a completely different direction, with its own independent orbital history. The mathematics of Atlas's trajectory are particularly intriguing. Tracing its path backward through space, astronomers can calculate where it came from and when it might have begun its journey. The results suggest an origin in the galactic thick disk, with ejection occurring sometime in the distant past, when gravitational interactions in crowded stellar regions were common. But here's where the story becomes almost mystical. The precision of Atlas's approach to our solar system seems remarkably unlikely for a purely random encounter. The probability of an object from the thick disk arriving at exactly the right time and trajectory to provide optimal scientific observations is astronomically small, perhaps 1 in billions. This has led some researchers to wonder whether there might be unknown gravitational focusing mechanisms operating on galactic scales, or whether our solar system's motion through the galaxy creates preferential pathways for intercepting ancient objects. Others suggest that we might be observing the tail end of a population of thick disk objects that have been arriving steadily over geological time, with Atlas simply being the first we've been technologically capable of detecting and studying. The implications extend far beyond Atlas itself. If the galaxy contains a hidden population of ancient objects wandering between star systems, carrying chemical signatures from the early universe, then we're potentially on the verge of discovering an entirely new category of cosmic archaeology. With every passing moment, this visitor reveals more, but our time to uncover its deepest secrets is rapidly running out. As we approach October 29th and 30th, 2025, the astronomical community is preparing for what may be the most important 48 hours in modern comet research. Perihelion will mark Atlas's moment of truth when this alien visitor finally reveals its complete nature under the full intensity of our sun's energy. Computer models predict that gases will pour out of Atlas's nucleus at unprecedented rates as frozen volatiles vaporize simultaneously across its entire surface. The tail will reach its maximum length, potentially extending millions of kilometers into space and becoming visible to the naked eye despite the solar glare. Every volatile compound locked within Atlas, since its formation will be exposed to detailed spectroscopic analysis. International coordination efforts are reaching fever pitch as observatories worldwide synchronize their schedules for maximum coverage. Radio telescopes are being positioned to detect molecular emissions. Infrared telescopes are prepared to map thermal signatures, and ultraviolet observatories are ready to analyze the high-energy processes occurring in the inner coma. The data collected during these crucial hours will fuel decades of research and analysis. We're preparing to capture the chemical fingerprint of materials that formed in an entirely different stellar environment, potentially billions of years ago. Each spectral line will tell part of the story of alien stellar nucleosynthesis, exotic ice formation processes, and interstellar chemistry that operates under conditions we can barely imagine. The cosmic alignment for studying Atlas couldn't be more perfect, providing us with a carefully orchestrated sequence of optimal observation opportunities spanning nearly 2 years. This timeline reads like a carefully planned scientific mission, almost as if the universe conspired to give us the best possible chance to study this alien visitor. October the 3rd, 2025, marks the historic Mars flyby at 18 million miles distance. This encounter provides our first opportunity for close-up analysis using the entire fleet of spacecraft orbiting the red planet. The geometry is perfect for simultaneous observations from multiple angles, giving us stereoscopic data about Atlas's three-dimensional structure and activity patterns. October 29th, 2025, brings perihelion, the moment of closest approach to the Sun and maximum activity. Atlas will be traveling at peak velocity of 152,000 miles per hour while experiencing maximum solar heating. Surface temperatures will reach several hundred degrees Celsius, triggering the most intense outgassing of its entire journey. Unfortunately, solar glare will make direct Earth-based observations nearly impossible during this crucial phase. December 19th, 2025, opens Earth's prime viewing window when Atlas reaches 170 million miles from our planet, but finally emerges from behind the sun's glare. This marks the beginning of the best ground-based observation period when every major telescope on Earth can contribute to the study. The timing coincides with winter in the northern hemisphere, providing long nights for extended observation sessions. March 16th, 2026, brings another unique opportunity: the Jupiter flyby. Atlas will pass close enough to the giant planet that NASA's Juno spacecraft might be able to intercept and directly analyze dust particles from its tail. This would provide the first physical samples from an interstellar object, allowing laboratory analysis of materials formed around another star. The Jupiter encounter will also provide a gravitational slingshot effect, slightly altering Atlas's trajectory and velocity. Precise measurements of this gravitational interaction will give us additional data about Atlas's mass and density, helping to constrain models of its internal structure and composition. After the Jupiter flyby, Atlas will begin its final departure from our solar system. Unlike some comets that return on predictable schedules, Atlas is on a hyperbolic trajectory that will carry it back into interstellar space, never to return. We have literally one chance to study this object, making every observation precious and irreplaceable. By 2027, Atlas will be beyond the orbit of Saturn and fading rapidly as it recedes into the outer solar system. By 2030, it will cross the orbit of Neptune and begin its journey back to the stars, carrying with it any secrets we haven't managed to unlock during this brief encounter. Soon, Atlas will vanish, but the lessons it leaves behind will forever alter our cosmic perspective. Atlas represents our third confirmed interstellar visitor in less than a decade, following the mysterious Oumuamua in 2017 and Comet 2 I/Borisov in 2019. Each visitor has been completely unique, suggesting that interstellar space contains far more diversity and complexity than we ever imagined. We're beginning to realize that our solar system exists within a rich ecosystem of wandering objects, each carrying stories from distant stellar nurseries. The frequency of these discoveries raises profound questions about what else might be out there, waiting to be detected by our ever-improving telescopes and detection systems. Are we witnessing the beginning of a new era in astronomy, where studying visitors from other star systems becomes routine rather than extraordinary? But perhaps most importantly, Atlas is teaching us that the universe is far more interconnected than we ever realized. We're not isolated on our small planet orbiting an ordinary star. We're part of a vast galactic community, connected by wandering worlds that carry the chemical signatures of distant stars directly to our doorstep. As Atlas races toward its solar encounter, it carries with it the hopes and curiosity of an entire species trying to understand its place in the cosmos. Every photon of light we capture, every spectral line we analyze, every detail we uncover brings us one step closer to understanding not just this alien visitor, but the broader story of how matter moves through space and time, connecting stellar systems across the galaxy in an endless dance of cosmic chemistry. The green glow of 3I/Atlas represents more than just a beautiful astronomical phenomenon. It's a beacon from another world, a signal from an alien chemistry that operated under different rules, in a different place, at a different time. When we look at Atlas, we're literally seeing light that has interacted with matter from another star system. We're witnessing alien chemistry in action. In just a few months, Atlas will complete its brief performance on our cosmic stage and vanish forever into the infinite dark between the stars. It will carry with it any secrets we haven't managed to unlock, any questions we haven't thought to ask, any mysteries we haven't been clever enough to solve. This is our moment. This is humanity's chance to study alien chemistry up close, to decode the signatures of stellar processes that occurred light years away, to understand how matter behaves in environments we'll never directly visit. Atlas is offering us a masterclass in cosmic chemistry, written in the language of light across the vastness of space. The story of 3I/Atlas is still being written, and we're all witnesses to one of the most remarkable scientific opportunities in human history. As this mysterious visitor completes its journey through our solar system, it reminds us that we live in a universe full of wonders, where the impossible becomes possible, and where visitors from alien worlds can still surprise us with their beauty, their mystery, and their secrets waiting to be discovered.